Okay, today we're going to talk about the other kind of quadrilaterals, but first I do want to go back to this map and I want to finish this up, okay? So we talked about quadrilaterals. In the quadrilateral family we have our parallelograms, and within that family we have these three special ones, okay? Today we're going to talk about two things that fit over here that are not parallelograms, okay? So our first one is going to be the kite. Okay, so a kite is a type of quadrilateral. A kite is not a parallelogram, okay? It doesn't fit in this family, that's why I put it over here. And then the other one that we're going to talk about is the trapezoid. Okay? These two things, they still fit in the quadrilateral family, they're just not parallelograms, which is why they're not over here. So we're going to talk about the kite and the trapezoid. All right, let's do it. Now we're going to have just some pretty basic little definitions of these. Okay, so a kite. You know what a kite is, right? You know what a kite looks like. Now obviously we have those kites that you actually float in the sky that have different shapes, but the original kite, that's what I'm talking about. So the definition of a kite is, first of all, it is a quadrilateral with two pairs of consecutive equal sides. Now there's that word consecutive again. What does consecutive mean? Yeah. Like my example the other day was that the softball team has won the state championship for 4 consecutive years. Repeating. Back to back. Next to each other. Okay? So in this case, a kite is a quadrilateral that has 2 pairs of sides that are next to each other. That's what that means. Next to each other, and they are equal. Okay? So let me show you what a kite looks like, and I want you to draw this. I'm going to draw 2 sides. Do those look about the same length? Pretty close, right? Okay, so I'm going to write my tick marks on there to show that they are equal. These sides are next to each other. They're literally touching, okay? And then I'm going to draw some longer ones. And these two are equal to each other, so they're going to have 2 tick marks. There's a kite, okay? Does that look like the kite that you imagined that floats in the sky? Yeah, it does, right? We're not going to do a whole lot with kites because there's really not a whole lot that I want to do with them, but I just want to make sure we understand 2 pairs of consecutive equal sides. So here's my first pair. These are equal. They're consecutive because they are back to back, okay? And then my second pair is here. They are equal, which is why they have 2 tick marks, and they are also consecutive, back to back, okay? The difference between this and our parallelogram is on a parallelogram the sides are opposite each other. Well, here the opposite sides are not equal, are they? These aren't equal, right? These aren't equal, okay? The opposite sides aren't equal. It's the consecutive sides. These two and then these two. For some reason, a lot of times in a kite, they draw in the middle line segments, okay? So let me show you what I'm talking about. I'm just going to draw another one. I'm going to draw this one upside down. Okay, so these two are equal and those two are equal. a lot of times with kites, for some reason, you will see these lines drawn in. Don't worry about those. That just really makes it look like a kite if you draw those in there. We actually call these lines diagonals. Diagonals. But for some reason, I don't know. Those are just drawn in there a lot. Don't worry about them. They're not part of the shape. That's just the inside. Okay? Questions about kites? Let's do one example of what we might use a kite to do, and then we'll move on to our trapezoid. Alright, I'm going to draw this one sideways. Ooh, I am drawing this one huge. That's okay. Alright, here we go. Got a kite. These are equal. These are equal. So real quick problem I want to do. Let's say if AB is 6 and BC is 10, I want to find the perimeter of the kite. You good? Alright, so this will not be hard. Just want to show you this, just want to make sure because there's going to be a problem like this on the worksheet here in a minute. So let's find the perimeter of this kite. Now, I've given you just enough information. What does perimeter mean? Y'all remember this one? Perimeter means the outside, all the way around the shape. So if I want to find the perimeter of this, I need to know each one of the sides on the outside. Well, they gave me this one is 6. And they gave me BC is 10. BC would be talking about this one, right? So they only gave me 2 of the sides. But we should know, how long is this side? 10. Because it's the same as that one. And how long is this side? 6. So now I know all of the sides. To find the perimeter, you're just going to add them up. 6 plus 10 plus 10 plus 6. So 6 plus 10 plus 10 plus 6, that's, yeah, 32. So there's my perimeter. Alright. We're done with kites. Let's look at the trapezoid, and that's going to be it, okay? Trapezoid. Make sure you write this down. This is the definition. Can you visualize what a trapezoid looks like? Is this one that we know? No? Alright, so this is a quadrilateral, obviously, with exactly one pair of parallel sides. Exactly one pair of parallel sides. Okay, so if the definition says it has exactly one pair of parallel sides, can it have 2 pairs of parallel sides? No. One and one alone. So let me show you how to draw a trapezoid. I always start with the parallel lines. So Now, parallel lines do not have to be the same length, okay? Parallel just means they're not ever going to intersect. So would y'all agree that these two lines I've drawn are parallel? Right? Yeah, they're just following along the notebook lines, so they're parallel. So then, to finish up this trapezoid, I'm just going to connect these here. Connect these here. I kind of missed there, but that's fine. There's a trapezoid. Are these lines parallel on the side? No. If we were to continue them, they'd eventually intersect, so these are not parallel. That's why it's a trapezoid. Only these are parallel. Let me show you what another one looks like, because they don't, we usually see them like this, but they don't have to look like this. Check out this one. Parallel. Yeah? Now this time I'm going to draw them straight down and then this way. Still a trapezoid. These don't really look a whole lot alike, do they? But they're both trapezoids. Okay, I'm going to draw you one more. If you want to draw it, you can. I'm going to draw these parallel lines going up and down. Those are parallel, right? Okay, and then connect them. Alright, so there's three different looking trapezoids. All of them are trapezoids. I want to do just a couple of examples of what we do with trapezoids. Okay, so I'm going to draw one more, a basic one. When you have a trapezoid that looks like this, and these lines over here on the side are congruent, this is a special trapezoid. Just to give you a little bit of information, we would call the two parallel lines, we would call those the bases. This is the top base and this is the bottom base. These lines over here, we call these legs. Doesn't really make sense to me, but they're called legs. Okay, so this is something that is unique with only this kind of trapezoid. When the legs are equal, the base angles are also equal. This is only true when the legs are equal, and that means you got to have tick marks on these over here, okay, to know that they are equal. So just to give you some letters, A, B, C, and D, what this means is we would call these the base angles, D and C. They are equal to each other. Angle D is going to be the same as angle C. But also, since this is the base too, these are also base angles. A and B are also going to be equal. Okay, so I just want you to see this. When you got this trapezoid, the top two angles are going to be equal and the bottom two angles are going to be equal. Alright, you don't have to write these next examples if you don't want to. I'm just going to draw some more diagrams. You've got the main stuff right here. That's basically the end, okay? Alright, so okay, in this diagram right here, I'm going to give you this angle is 21 degrees. Say I wanted to know angle C. Now, just because this is drawn sideways, these are still your bases, okay? So imagine if this was turned. These are your bases. Angle B is going to be equal to which one? If I turn it this way, angle B is going to be equal to which one? All right, let's look at this one up here. We said the base angles are equal, D and C are equal, A and B are equal. Help me out now. This one is going to be equal to which one? No? The one along the same base. Okay, so here's my base. The bottom two are going to be equal, and the top two are going to be equal. Y'all see that? Bottom two are equal, top two are equal. So if I turn it back sideways, angle B is equal to which one? C. So if it says find angle C, very easy. If B is 21 degrees, then so is C. All right, let's do one more of those. I'm going to draw this one normal. All right, now this one's going to be trickier. Maybe I shouldn't do that, but I am. All right, now this one's drawn just like the one at the top. I'm giving you angle R is 100. I want to find angle T. So first of all, your top angles are equal. So these are both how much? 100. And then your bottom angles are equal. Now in this case, I'm asking you to find this one. So I do not know what M is. Are these going to be equal? Not necessarily. Okay? The top two are equal. The bottom two are equal. The question is, how are we going to find this one? It is not necessarily 100 degrees. That's a good way to do it. I'm going to show you an easier one, but what you've got is actually a good way to do it. If these lines are parallel, and they are, and let's say I pretend this is my transversal. Do y'all remember the relationship between these two angles? Same side interior. Good. They're same side interior. And same side interior angles add up to how much? 180. So if these add up to 180, all I have to do is 180 minus 100. That tells me angle T is 80 degrees. So they didn't ask for it, but what would angle M be? 80. The bottom two are equal, the top two are equal. All right, I want to do one more. Again, you don't have to write this one down. I'm just going to introduce just a little algebra here. All right, I'm going to say that this angle is 5x minus 26, and this angle is 2x plus 10, and I want to find x. Now this is generally pretty easy. Are these two angles equal? Right, they are. The bottom two are equal, the top two are equal. So if I want to find x, these are equal. 5x minus 26 equals 2x plus 10. This is the equations that we were solving yesterday. Help me out. What do we want to do with these two things? We want to get them together on the same side. The easiest one to do is to move this one. To move it, that means subtract it. Those cancel. 5x minus 2x, anybody? 3x. Bring this down, bring this down. It helps if I ignore what I've got up here. Do we know how to solve this equation? We should. What do? Add 26. That gives me 36. What's the last thing I do? One more step. Divide by 3. So x equals 12. Said find x. X is 12.